Today we're going to look at an example of a one-sample z-test for a mean, and the method we are going to use is the p-value method. So our first step is to read the problem and decode it. A researcher wishes to see if the average number of sick days, so we already have something important, that a worker takes is greater than 5. So that tells us immediately what that researcher wants to collect evidence for. So we can start to write our null and our alternative hypotheses. So that's step 1, so my null hypothesis, and then my alternative. The researcher wants to collect evidence to support that the average is greater than 5. So population average is mu greater than 5. That means my alternative is going to be mu is equal to 5. We could also write this equals as less than or equal to. Those are both equivalent forms. Connect once the equal. So this tells me that I have a right till test. If we keep reading, we have some more information. A random sample of 32 workers at a large department store had a mean of 5.6. Well, this mean is of my sample of those 32 workers, so that's x bar. The standard deviation of the population, so of all workers, is 1.2, so that sigma is equal to 1.2. Is there enough evidence to support the researcher's claim at alpha equals 0.01? Well, if we're going to use the p-value method, we need to first write our hypotheses, which we've done, and then second, we need to find our test statistic. So to find our test statistic, we need to know what distribution we're working with. Since we are given the population standard deviation, and my sample size is greater than 30, then I can use the normal distribution, the z test statistic. So here we're going to find our test statistic. We know we are working with the normal distribution because, again, we were given the population standard deviation and my sample size is greater than 30. So let's go ahead and sketch a normal distribution. Maybe something like that. And to find our test statistic, we have a formula for that. Z is equal to the sample mean minus the population mean all over sigma divided by the square root of n. We actually have all of this let's make that a little bit neater. We have all of this information already. X bar was given to us. That is 5.6. We got that from right here. The mean, population mean is given to us as 5. That should be 5.6. Sigma is given to us at 1.2. And the square root of n is 32. So when I put that into my calculator, I got approximately 2.8284. That is my test statistic. So if this is my normal distribution, the mean is 0. 2.82 is maybe somewhere right in here. So this is where my 2.8284 is. A p-value is the area in the tail from your test statistic all the way to the tail. So I want to know what is this area. I want to find that p-value. So for the p-value method, we found our test statistic, and now we're ready to find our p-value. The p-value, again, is the area in this tail from my test statistic to infinity. So since we have the normal distribution, we want to accumulate all of this area. So to find our p-value, we are going to use the normal CDF. We're using the normal CDF because we are working with a normal distribution, and the CDF is accumulating the area. For the normal distribution, it takes in a lower bound, CDF. The lower bound is this 2.8284. The upper bound is infinity. Your mean is 0 and your standard deviation is 1. So when I put that into my calculator, I ended up getting 0.002339. This is our p-value. Now, if we had a two-sided p-value, if we would have shaded area in over here, then I would need to multiply this p-value by 2. But since I just have a one-tailed test, then the area in the tail from this test statistic all the way to infinity is 0.002339. So now that I have my p-value, we can make a decision. So our decision is we're going to ask ourselves a question. We're going to say, is the p-value less than or equal to alpha? That's our question. Well, our p-value is 0.002, and our alpha, so let's write that in there, 0.002339, and our alpha is 0.01, I believe. Let's just double check that. 0.01, yes. And it is true that our p-value is less than alpha, so then we reject the null. So for our little rule up here, p-value is less than or equal to alpha, this is our rejection rule. So this implies that we reject alpha. Okay. Well, now we know our decision. We've rejected alpha, but what does that mean? So we come back up here. If we reject the null, then we have evidence to support the alternative. We have evidence to support that the average days missed is greater than 5. So our very last step is to write a conclusion. So let's see, at the alpha equals 0.01 level, we have enough evidence to support, let's write that a little bit nicer, enough evidence to support the claim that the average number of days missed is greater than 5. All right, if you have questions, feel free to email me.